Hey everyone, Russ here. Today we're going to talk about Dalton's law of partial pressures of gases. Indeed, what Dalton says is that if you have a mixture of gases at different pressures, the sum of all their pressures will add up to the total pressure. Now let's look at that in an example to make it more clear to us. Here we have pure helium at 2 atmospheres. Here we have pure argon at 4 atmospheres. If we magically somehow mix these two things together in the same volume, you'll get 6 atmospheres, as long as the volume didn't change. Okay? So now, what I'm trying to get across to you is that the sum of all the partial pressures of each gas in a mixture will add up to the total pressure. Should make sense, right? Because if you think about the way gases work, they're not thinking or hearing or sensing. They're just reacting, right? If a helium atom doesn't know the argon atom is there, it's just going to bounce against the wall of the container. And bouncing against the wall of the container is what causes pressure. So if you have two atoms hitting the sides of the container, that's just going to help add to the pressure. Doesn't matter what the gas is. Okay? So keep that in mind. So here's Dalton's expression for partial pressures. Just P total equals P1 plus P2 plus P3, and so on and so on and so on, depending on how many gases you have in the mixture. Okay? Very simple calculations. Now, first we have to understand what standard temperature and pressure is. Standard temperature and pressure, or also known as STP, is 0 degrees Celsius and 1 atmosphere. So here's the deal. It's called molar volume. If you have 1 mole of a pure gas at standard temperature and pressure, you will have 22.4 liters. That's just molar volume. That's what it's called. Okay? If you have a mixture of gases at standard temperature and pressure and 1 mole, you will also have 22.4 liters. The take-home message is here, it does not matter if the gas is pure or not. It can be a mixture. At STP, standard temperature and pressure, 1 mole, you're still going to have the same volume. That means pressures are additive. That's what it tells us. Okay, you can add them up. Okay, as long as there's 1 mole, the moles don't change, and the pressure doesn't change, the volume won't change. Okay, whether it's pure or a mixture doesn't matter. Keep that in mind. Of course, it's chemistry, so we ask you to calculate stuff. And the way to make partial pressure questions difficult is simply to change the units of the pressure. And you'll see that in this question here. A scuba tank contains O2 at a partial pressure of 0.450 atmospheres and helium at 855 millimeters of mercury. They gave you 2 different pressure units, so you can't add them up because they don't have the same unit. What is the total pressure in millimeters? So it wants us to be in millimeters of mercury. Okay, so the hard part here is you have to recognize that you have to convert atmospheres to millimeters. Okay, so that's easy. I gave you the conversion factor right there. So let's convert atmospheres to millimeters of mercury. So first we start out with atmospheres multiplied by something to give us millimeters of mercury. Atmospheres go on the bottom, millimeters of mercury go on top. We know that there are 760 millimeters of mercury in 1 atmosphere, and we know we're starting with 0.450 atm. 0.450 multiplied by 760 equals 342 millimeters of mercury. P total equals pressure of O2 plus pressure of HE. That's going to be 342 1,197 millimeters of mercury. That's the total pressure from those 2 gases in that tank. Let's do another one. It's always good to do a couple of examples, guys. Make sure you command it. For a deep dive, a scuba diver uses a mixture of helium and oxygen at a pressure of 8 atmospheres. So the total pressure, so P total, equals 8.0 atmospheres. If the oxygen has a partial pressure, so the PO2 is 1280 millimeters of mercury, what is the partial pressure of helium? So P helium equals question mark. Again, hardest part about this question is recognizing that you have to convert one of the pressure units. And what is the partial pressure of helium? It doesn't tell us how it wants the pressure reported, so we can do whatever we want. We can either convert atmospheres into millimeters or millimeters into atmospheres. I'm going to go with converting atmospheres to millimeters, just because I find it a little bit easier. 8.0 atmospheres multiplied by something to give us millimeters of Hg. Atmospheres on the bottom, millimeters on top. 1 atmosphere is 760 millimeters. How about your calculator? 8 multiplied by 760 equals 6,080 millimeters of mercury. P total equals PO2 plus P helium, right? He. So we need to know pressure of helium. So P helium equals P total minus PO2, which is going to be 6080 millimeters of Hg minus PO2 is 1280. Final pressure is going to be 4,800 millimeters of mercury. There you go. Now, if you guys like that video, please consider subscribing to my YouTube channel. That really helps me out. Slap that like button and leave a comment below. Let me know if you had an easy time or a hard time with these problems. And then it'll just generally engage with me about this content. And with that, I want to wish you all good luck and good chemistry. We'll see you soon.